Yeah, we can.
Yes.
Fantastic. All right, so this session started off as Azure SQL database for the production DBA, and that's when it was Azure SQL, and then we got hyperscale, we got serverless, we got managed instance, and all these other things. And as I would present, those were the questions that would come up. So I've now taken a lot of material, threw it into a single session. So I am with SQL Skills. I get to work with Paul Randall, Kimberly Tripp, Aaron Stellato, and Jonathan Cahias. So a really cool team to work with. We do instructor-led training. Previously, that's been on-site. We're now doing it virtual thanks to COVID-19. It's been funny. I've seen a number of surveys on what was the driving force for the digital transformation for your company. Was it the CEO, the CIO, the CTO, or COVID-19? So for us, that's kind of catapulted us into doing much more online training. One of the takeaways here is if you're not a SQL Skills Insider, I encourage you to become one. We send out a newsletter every 2 weeks. It's not a markety, spammy type newsletter. There's technical content. There's an insider video that we record. The one that went out this week was talking about infrastructure as a service, with a resource provider so that you could have the auto patching, auto updates, and convert over to pay-as-you-go licensing so you can scale up and scale down. So it's a lot of technical content, as well as kind of, hey, what's going on with the team? So make sure to sign up. I mentioned our classes. Those are coming up next week, beginning, I believe Mondays is the beginning of our IE0, which is the accidental DBA. Tuesday, I start a 8 half-day track on Azure, all things Azure. So check those out. If you're not a Pluralsight subscriber, email Paul at sqlskills.com. He'll send you a code for 30 days of all the SQL Skills content, which is over 188 hours. So you have 30 days to try to cram in all 188 hours. Good luck. And I have a couple of courses out there on Azure. We have lots of stuff out there on performance tuning and Service Broker. Jonathan Cahias has a new course out there on using the SQL Sentry or Sentry One Plan Explorer. So that's kind of cool. I think somehow he was able to get about 2.5 or 3 hours worth of how to use Plan Explorer, which is a free tool, doesn't even ask for an email address, to troubleshoot SQL Server performance. So it's phenomenal. My About Me slide, the takeaway here, my email address, tim@sqlskills.com, on Twitter @tradney. I blog on SQL Skills and then my own personal blog. And then the trivia about me, I'm into electronics. Of course, I'm a geek. I do aquaponics. I have tilapia that are raised in tanks and I use that water to irrigate crops. I have chickens and then a relatively large garden. And when people ask about the garden, this is my some random shots of my 2020 garden. So the bucket of peas, that's about 1.5 gallons of peas. The tiller on the bottom right, I just picked up today. But yeah, that's where I spend my time, is outdoors as much as possible, playing in the dirt. So what are we going to talk about in relation to Azure? First is we need to understand what platform as a service is for Azure SQL. So Azure SQL is now a family product name. So Azure SQL, you have Azure SQL Database, Azure SQL Managed Instance, Azure Hyperscale, Azure Infrastructure as a Service, or Azure SQL VMs, I think is what they want to call it. So pretty much everything with SQL Server is going to be under an Azure SQL kind of umbrella. But your platform as a service is going to be your SQL database, your managed instance, those where we subscribe to a service and we have a product. So we'll talk about platform as a service benefits. So just as you get into that environment, what are things you inherently have access to? We'll talk specifically about SQL database, elastic pools, then we'll jump into managed instance, and then what kind of sets managed instance apart. So your overall platform as a service, think of this as your Azure cloud services. It allows us as technical people and engineers and application developers and so forth to focus on our applications and growing our business, and not so much the hardware and the plumbing between all the equipment. There's full life cycle, so we can do development, we can test, we can deploy. I mean, all of that just all in the cloud. You have teams that can be all over the world looking at the same data sets. We have auto scale for certain components. Think about websites. You run a Super Bowl ad, you have a lot of influx, you can automatically scale up to handle that and then scale back down so that your cost, you're only paying for the compute that you consume. So you scale up, bigger bill, scale back down, smaller bill. For SQL, it's a little different. We'll talk about that. It's super compliant. I mean, there's the Azure Trust Center. You can go and look. I mean, PCI, HIPAA High Tech, DSS. I mean, all of these things, Microsoft has gone through the certification process for the infrastructure and a lot of the components. And they'll actually spell it out, what they cover, what is shared responsibility, and then what's on the consumer. Being that I came from finance, PCI was a big thing, and I had to go through a PCI exercise. And most of the bits that we as the financial institution were responsible for was documentation. What are our policies and procedures about X? And then how are we securely doing things? How are we preventing access to certain, to the data on a need to know? Well, if it's Azure SQL, we had a lot of tools like encryption and dynamic data masking, things like that. And those things were listed to kind of help guide us and show us, hey, implement this and you can achieve the certification on your side. So lots of benefits just from the general platform as a service, whether it's Azure SQL or MySQL or some other component. Where does SQL Server fit into this? Well, your Azure SQL database, your Elastic pools, your managed instance, they're all built in this platform as a service. So each one of those products get to take advantage of those benefits, such as dynamic data masking. Mentioned security. You can tell by the early days of Azure SQL that the whole concept of moving data sets into the cloud were, the security aspect was at the forefront. So we had dynamic data masking and row-level security that were introduced in Azure SQL Database about a year before SQL Server 2016 was generally available. So it's Azure first, then we got to see it in SQL Server 2016. And with dynamic data masking, what it allows us to do is change how the data appears in the result set. Most of us support commercial off-the-shelf software. We have software that we bought that our end users are consuming and using. And if you sit down and you look at each individual job, data that they're seeing on the screen, many times they're seeing stuff that is not relevant to their job. They're seeing full account number, customer's email address, customer's telephone numbers, that they may never do anything with it. But the software developer thought, hey, well, they'll probably need this, we'll return it onto the screen. When in reality, they don't need to see that, or they could get by with a subset of that data. With dynamic data masking based on the user's role or their login, you can change how that data appears. So maybe for email address, they only see the first letter and then everything else is X's. Social security number, email, account number, things like that, maybe the last few of that account number. All that is rules that you get to apply, and it's within the database engine. There's no actual change to the data. So there's no real risk of breaking an application or a vendor saying they don't support it, because it's just a masking rule that's applied to the result set. Similar, row-level security takes it a step further. Think about if you have customers that are also employees. Maybe you don't want all employees to be able to see all customers' data. You want to filter out that only a few managers can see employee data. So now, based upon the role, the user's identity, you're restricting the result set based on that. So if employee status equals 1, they're an employee, that the regular teller CSR type users can't see that result set. So 1 million rows in the table, 800,000 are external customer, 200,000 are internal. Select star from table. They're only going to see the 800,000 rows instead of all 1 million. So this takes it a step further. It's kind of neat to be able to filter the result set just based on the user's identity. I've seen a lot of implementations of this, and usually it's tied to a certain type of customer. Maybe it's a celebrity, maybe it's employees is very common, but there's solutions that this solves, or there's situations that this easily solves for. To do either one of these things manually yourself takes, hours, if not hundreds of hours of development, extra storage. It's been a real pain. So these two features have been very welcomed. So let's take security a step further. Always encrypted and transparent data encryption. So TDE, your transparent data encryption, has been around since SQL Server 2008. For many of us, it's been a checkbox. Auditors, examiners got a hold of this. Oh, encryption at rest. We're requiring it for a multitude of different, certifications and regulatory requirements. And it solved a big problem. We had data files and log files encrypted at rest. TempDB became encrypted. Your backups were encrypted. And that was a huge win early on. With modern hardware and infrastructure, the amount of overhead for TDE is so minimal that for Azure SQL Database and for managed instance, it's actually on by default. What TDE hasn't given us is if somebody were able to compromise a user account, a login password, and was able to query the database, they could still see all the data in the database. Nothing was actually encrypted for a select query. If you were able to query, you could see all the data, dump everything out. What it protected against was if somebody got the backup file or the storage array and then tried to mount that database. If they didn't have the asymmetric key, they're not seeing the data. So it provided protection, but not as much as we would have liked. And this is coming from a information security perspective. What we have with Always Encrypted is we can now actually encrypt the data in the storage engine. So you have credit card data, you have social security number, you have very sensitive data. You can encrypt the data in the data file itself. So now if you go to query, say, social security number, you don't have the encryption key, you're going to see garbage. You're going to see, like GUIDs, you're going to see random data, you're not going to see plain text. What this allows us to do is protect data from even DBAs. Even though you're a systems admin, if you don't have the encryption key, you're not seeing the plain text data. So we can now restrict this to just the application servers, the web servers, and truly take the encryption to the next level. There's Azure Key Vault integration for both Always Encrypted and transparent data encryption. So anytime you start working with encryption, key management is critical because you lose the keys and you're trying to restore the data or access the data. There's not a backdoor. You've got to have your keys. So proper key management is key here. So Always Encrypted TDE for your levels of encryption. When a bunch of MVPs were kind of interviewed and asked when SQL Server 2016 came out, what were your favorite features? Number one was query store. Number two was Always Encrypted. So I would love to see some type of report of the adoption rate, for Always Encrypted. And one of the things here is you can encrypt the data either deterministic or I think that it's random or deterministic. So random, if you have ABC, it's going to be different every single time, versus deterministic, ABC will be encrypted the same time each way. So ABC would always be represented with the same encrypted value. So when you're trying to do conditions for like where equals and things like that, it's better for the system. So always test before you go start turning these things on to see how it would impact your application. Still on the security aspect, one of my favorite bits is the threat detection. This is where you can subscribe. It's $15 a month per server. So Azure SQL Database servers, so not just per database, it's for the server or your container, per managed instance, per virtual machine, it's per server. So with the threat detection, it allows you to see where there's potential threats as they're occurring. Or you subscribe to a service that there's been some type of new vulnerability or threat vector that's been applied. It actually takes a look and baselines your environment to determine suspicious activity. So think about your credit cards. If you're traveling across the country, you fueled up in Atlanta, Georgia, and then I fly to Seattle, and then I swipe my credit card at a Starbucks or something there, I'll get a text alert. Hey, we just noticed that 6 hours ago you were in Georgia and now your card's being used in Seattle. Is this you? Reply yes, and then my card's still good. you know, things like that. So if it sees that, I'm typically logging in from Columbus, Georgia, and then all of a sudden I logged in from Chicago, Illinois, hey, is that you? Did you log in from here with your credentials, accessing this particular database? So it's looking for things like that. It's also looking for, think about the amount of data. Well, I usually query and I'm moving around a couple hundred megabytes of data. All of a sudden now I'm pulling gigabytes of data. Is that something that, someone would want to look at? Maybe. Did I just put in my notice? Am I pulling down the entire customer database? So things like that. It's looking at and seeing where there's anomalies and notifying. It may be false positives. It may be preventing the next, target data breach, Equifax, those types of situations. And this is built in. I mean, you have access to this for $15 a month per container or server. Even though you may have something else in place within your organization, that low of a cost, I can't justify why somebody would not want to subscribe to this. We also have vulnerability assessments. This is also built into SQL Server Management Studio. With the Azure side, you can schedule it. It's going to run. It's going to provide you with a list of potential vulnerabilities based against a knowledge base. What's nice is that you can approve certain things as part of your baseline. So yes, I know I have this user account that has excess rights. There's nothing I can do about it. Approve it as part of the baseline so it doesn't keep you reporting on this month after month. So once you go green, everything looks good. Then the next month or the next week that your vulnerability scan is run, if anything's in red, it's something net new that may be actionable. And what's nice with these reports is it gives you, it's not just, hey, this is bad. It's, hey, this is bad. Here's the reasons why, and here's ways that you can mitigate that vulnerability. Every organization should have something in place where they're getting kind of regular scans, whether it be from a product like Qualys or something within their environment. Most of those things are looking for Windows patches, for Adobe, for Office type products. With these, with Management Studio and the vulnerability assessment within Azure SQL Database, this is actually looking at your SQL Server instance and users' permissions, things like that. So it's way deeper into our actual product, not just the, hey, you're behind on Windows and cumulative updates. So definitely take a look at it. And of course, we have Azure Active Directory integration. If you have a local Active Directory, you can synchronize that up to Azure Active Directory. I don't really recommend DBAs be the ones responsible for this. Hopefully you have some identity management people in your organization that this is what they do. To sync the two, there's Azure AD Connect. It's pretty easy. I was able to do it in a lab environment. So if I can do it, anybody can. And then I was able to replicate up all my local users into groups and things into my Azure Active Directory, and then provision those to SQL database, manage instance, virtual machines, and so forth. So that's nice. With it being Microsoft, it just integrates. I mentioned the compliance stuff. Go geek out on this all you want. If you're having trouble sleeping, just go pull it up and start reading ISO standards. I just put up a few of the common ones here in the US and snagged a few from abroad. If it's something that's pretty big and critical, regardless of the country, Microsoft has most likely approached it and gotten the certification, and you can go read up and see what's required of you to then meet that those requirements. From a Azure SQL Database perspective for PCI, it was something crazy like 60-something% of the requirement was on Microsoft. I mean, handled by them. And then 30-something% it was on the company, the customer, using Azure SQL Database. And of that 30-something%, more than 3/4 of that was just documentation. What are your policies and procedures about X? The rest was actual things that you need to do, like firewalls and locking down access based on users' identity and so forth. So from that, very little actual work. It was mostly paperwork. All right, so we're in platform as a service. We have automated backups. This was hard for me to kind of digest, being the on-premises kind of SQL Server DBA, manager DBA, that I can't do backups in Azure SQL Database or Managed Instance, that they're done for me. Now, technically in Managed Instance, yes, I can still do copy-only backups, but the actual fulls, differentials, transaction logs, all of that is automated. And to restore, I go into the Azure portal and I choose restore to a point in time, and then it restores to a new database name. Restoring to a new name is kind of important. Now, there's a few reasons why they do that. If they allowed you to restore and overwrite, now what happens to all that backup history for Radney Tim as the database name? If I overwrite it, well, now that's a new full, and oops, that was a mistake. I didn't mean to overwrite it. That's just way too cumbersome to try to allow a end user to go and undo that mess. So you're forced to restore it to a new name. You can then rename Radney Tim to Radney Tim Bad, and then the newly restored database to the proper name, reconnect your application and go. Or just restore it to a new name, get the data out that you need, fix production. So just be aware that one of the reasons I kind of point this out is if you're in a singleton type environment where you're paying per database and you just restored the database, that's a net new charge. So you want to fix whatever and then either drop the, scale this down to the lowest you can to save on cost, or get rid of it as quickly as possible. If you're in an elastic pool, a managed instance, it's really just counting against your storage at that point. So you can keep it around as long as you want, and storage is much cheaper than compute. Your retention is up to 35 days. It defaults to 7. So you want to go and increase that up to your proper retention period. And just know that as you store more data, there is backup storage cost. It's not super expensive, but it does add up if you start stretching out to the 35 days. Lots of built-in HA, especially when it comes to storage. I mean, there's 3 copies of your data. You're guaranteed the SLAs on storage, I believe, starts at 11 nines, which is 0.03 seconds of downtime per year. So pretty much if your data is on disk and it's committed to disk, you're protected from it going away. There's very little chance that that data is going to be destroyed or go away. For SQL database, we have geo-replication. You can replicate all tiers of Azure SQL database to another region. It is a readable secondary. There's very low latencies for your estimated recovery time and recovery point objective if you're in the preferred data center. So East US to West US, East 2 to West 2, central to the other central. I mean, there's preferred data centers for your geo-replication. You can geo-replicate pretty much anywhere to anywhere, and it's still relatively low latency, but the SLAs, published SLAs are for your preferred failovers. And there's other geo-replication with virtual machines, storage, and more. But from a SQL database, you've got a readable secondary, so that is something that you're paying for, and it's something that is really great to offload your read-only workload. So you have reporting, Power BI, things like that. Point it to your geo-replicated secondary and offload that off your primary. I've had a number of customers that have set up their reporting off the secondary, and they were able to drop the primary compute by half, and that other half was their replicated secondary. So they got DR, they got the checkbox at no additional charge, because think of a P4, 2 P2s costs the same as 1 P4. So if it's a 50-50 split, or even a 75-25, can reduce primary read-write down, and then your secondary scale it up to handle that 25%, and you can truly have a net zero cost disaster recovery, and then offload that read workload. If you have to fail over, scale up. It's pretty quick to scale. If you're using in-memory OLTP, it's available for you in the Azure SQL Database Premium and in Managed Instance. Your amount of in-memory optimized tables, of course, grows based upon your tier. The higher up you go, the more memory you have available to leverage for in-memory OLTP. And then we have this thing called auto-tuning. So auto-tuning's been around in Azure SQL Database for quite some time. This is the area where some DBAs start getting freaked out on, oh my gosh, if we move to this, I'm going to be out of a job. So up to this point, unless you're just installing SQL Server and responsible for backups, if that's your sole job, yes, you could be in trouble. But if your sole job is installing SQL and managing backups and creating, covering indexes, then okay, you might be in trouble. I've taught this class, this particular one, I mean, probably 100+ times, many times in person. And when I've asked, who gets to proactively tune queries, where your job, you spend some amount of time per day or per week proactively tuning, I've had one person out of thousands raise their hand. Most of us, we tune when users complain or we get a call where all hands on deck, there's a problem with production, and now we're going out proactively, trying to create indexes. Who only tunes creating indexes? Most of the time we have to refactor some code. We have implicit conversions going on. We have some really gnarly T-SQL that's not just fixed from creating an index. So although this is an auto-tuning, auto-creating new indexes, auto-deleting unused indexes and duplicate indexes that have not been used, that solves just a small portion of a problem. When you go and look, many times you'll see that, hey, it applied an index and then it reverted the index because it didn't get the benefit that it thought. So it is a good thing to have enabled. I have no customers that have enabled and then gone back and turned off. One of the really big benefits here is the force plan. When you're coming from SQL Server 2012 and below to SQL database, you're also getting the new cardinality estimator. So we have potential regression issues. Even coming from 2019 and below, if you're still at a compat for 2012 and below, then you're introducing a potential new cardinality estimator if you're at compat, 2014 and above. So the automatic force plan is if there's, query comes in, execution plan's created, we have a regression, we have another execution plan, and we see within this workload that, one particular execution plan is better, it can force that. So it can automatically do that for you. SQL Server 2017 Enterprise Edition can as well. It's automatic plan correction. With this, we can go in and see with Query Store where all force plans are in place and then go do some research. So this is a really good tool, a really great feature to have. It is only available in Azure SQL Database. So your Azure SQL Database, your Elastic Pool, anything that is an Azure SQL Database, regardless of your pricing tier, your managed instance is more like a 2019, where it's a automatic plan correction within the full instance. So you have, it's the on-premises look feel, not the automatic or the auto tuning. So recommendations here, this is now on by default. It was, you had to go and enable it. Now, forget which month, but I believe it was this year that they started forcing. This is now, you create a SQL database server, it's on, each database inherits from the parent, from the server. So it's going to be an on by design. So if it's something you don't want, you can go and turn it off. You can still get the recommendations and manually apply them as you need or as you see fit. And what you'll typically find is you're applying everything that it recommends, and then you go and turn it on, and then just kind of spot check. But again, this isn't replacing us. It's a nice to have. It prevents a few fires, but we still have to look at ugly code and make recommendations to developers to actually fix the root problem. Query Store, mentioned it previously. If you're not very familiar with Query Store, go watch Aaron Stellato's Pluralsight course. If you have a Pluralsight subscription, go watch the course. If you don't have a subscription, email Paul, go watch this course. Then go look her up on YouTube. There's a lot of updates from the time the course was created. Now we have SQL Server 2017, 2019, there's been updates. She has an entire category on her blog. Joey from Denny Cherry and Associates was just talking about this. Absolute, hands down, one of the best ways to go and find out what's happening right now and start doing some performance tuning. This does not replace what Devin just showed us with DB Sentry and those tools. Query Store shows us query aggregations and runtime statistics, but we're not getting disk latencies and CPU utilization, page life expectancy, all those other things you need as a baseline. QueryStore is telling us our run plans and runtime information that we can see what's happening with our queries. This is persisted into the database. You do a backup and restore for 2016 and above, QueryStore is still there. It's stored in the primary data file, which is awesome because now you can take that database, restore it, not in Azure, 2019, Azure IaaS, yes, but not the PaaS environment. You can restore in a dev environment, see what was going on, make changes, see how that impacts the system without actually touching production. But in SQL database, QueryStore is on by default. On premises, you have to turn it on. It's on by default in SQL database because this is what Query Performance Insight uses to generate all your recommendations and everything else. So we definitely need to be more intimate with QueryStore and how to use it. And it's something you can turn on and then turn back off. Turn on during peak time, capture some data, turn it off, go analyze it. So where does SQL database? This is our database as a service. So get that mindset, database as a service. If you have customers that ask for a new database, you create a database, you give them access to the database. Maybe they're DBO, they can create objects, they can create tables, they can insert data, delete data, do all those things, stored procedures, whatever. Maybe even make them database owner. They can drop the database. They can do whatever they want to the database, but they cannot do anything at an instance level. Congratulations, you're Microsoft giving them an Azure SQL database. I mean, it's database as a service. None of that instance level stuff. I have a database, what can I do with the database? I can put data in, I can take data out. I can create objects, stored procedures, I can use it and abuse it. It's a data store. And that's what we get. So it's our cloud relational database as a service, 4 nines of availability built in. We do have the ability to purchase compute, it's called an elastic pool, and put a whole bunch of databases in that. So we're not having to micromanage each individual database compute. I mean, imagine that if you had a SQL Server instance and you were forced to use a resource governor and allocate how much memory, CPU, and disk IO each database could have. And that was the only way that you could administer a SQL Server instance. That would be aggravating, mind-numbing. It'd be awesome for some environments, but as a default, that'd be bad. So for SQL database, it's database scoped. You have singleton databases, guaranteed levels of compute, but maybe I don't want that. I want a pool of resources that they can scale up, scale down automatically within, use the resources, and I just kind of manage the pool of CPU memory and IO. That's your elastic pools. So that's awesome for unpredictable workloads where I'm just kind of balancing, making sure I have enough for different time zones and workloads that are coming in. When SQL database came out, most of our tools just still worked. It looks like SQL Server, feels like SQL Server, acts like SQL Server. Our tools, libraries, APIs, they all still work. SQL command, SSIS, SSRS, it's just a database. And we can scale up, scale down with minimal effort. Depending on your application, it might not even notice that it's scaling up and down. If it breaks the connection, if there's a blip in the network, then your application's not really cloud ready. But if it can retry, then you can scale this up and down. Certain applications, I mean, depending on if the resources are available, it may have to kind of migrate you somewhere else. Think of it like a live migration. But there's going to be some pinged loss. So reconnect, then you're good to go. And we talked about the security and compliance. What are some differences, things that don't exist? I kind of used to refer to these as limitations, but it wasn't really a limitation or a missing feature. It was just stuff that SQL database wasn't designed to do because it's database scoped. SQL Server Agent, database mail, I mean, those are things that are instance level. So they don't exist for Azure SQL database. We can still use on-premises. We can spin up an Azure virtual machine running SQL Server and use the tools that we're used to, or we can use Elastic Jobs or Azure Automation, which are the cloud orchestration tools. For database mail, we do have alert rules for certain conditions, but if we need database mail where, hey, if a condition exists, fire off an email and do something, leverage Azure VM or on-premises. The biggest gotcha was there's no cross-database query support. Meaning if I have 2 databases, they need to talk to each other like they can on a SQL Server instance. it wasn't designed for that. It's database containment. I need a database per customer. I'm a SaaS vendor. I need one for each of my customers, and they don't need to see anything from each other because that would be violating all kind of rules and regulations and so forth. This is what SQL database was designed for. Application that has 4 or 5 databases, they all got to talk. This isn't the place for you. Manage instance is where you should be. There are elastic jobs. Maybe I'm a SaaS vendor. I have a database per customer, and I need to get the same information out of every single database to go into a data warehouse. I can schedule elastic jobs to go do the same select across all of them and insert into another table. So there's benefits. All right, events and notifications. So we have these certain alert rules we can configure, but your regular event notifications, query notifications, those are not supported. Trace profiler, people use extended events. I mean, it's been there, for the 5-6 years now in SQL database. So think about the overall how trace profiler works. It's instance level. So you'd be getting stuff at the kind of the Azure server container level, not just your particular database. And then instance level trace flags or anything requiring SP configure. Reporting services, integration services, you can still leverage those. It just points to Azure SQL as a data source, or you can start switching over to the cloud-ready products like Power BI and Azure Data Factory. And I have a lot of customers that when we've done migrations, we've focused on the database. Let's get the database there. Let's spin up IaaS for infrastructure as a service, for integration services, reporting services. Those are big major initiatives and projects. Let's treat them separate. Let's not just migrate it all and try to reverse engineer everything. Let's focus on the database and your front end, your web front end application server. And then now let's have a project for reporting. Let's have another project for SSIS. And usually it's those teams are having to come up on the new technology as well. So don't think you have to do it all at one time. You can't log ship, database mirror, or set up an availability group to an Azure SQL database. You can set up transactional replication. That's a fantastic way of replicating up to a SQL database and doing a cutover with minimal downtime. But SQL database cannot be a publisher. So it's a one-way. I can move up into it and then I'm there, can't come back. You can log ship mirror availability group to an Azure VM running SQL Server. That's a great way to pre-stage your data in the cloud. And then when you're ready to cut over to SQL database or manage instance, then you can do the migration there. You don't have to wait on the copy from on-premises to cloud. You're already pre-staged in the Azure data center that you're going to be in. So now it's just the extract and import. Your overall pricing, there's database transaction units. Devin mentioned DTU as a metric in one of the screens. If you're using vCore pricing, you would see CPU, but DTU is that standard premium, basic tiers was the early methods of setting up a SQL database. This is where your license for SQL and everything were all bundled in, and a DTU is a blended measure of compute, storage, and IO. So basic, standard, premium tiers based upon your overall compute and IO requirements. You could find a tier that works pretty well for you. We're still going to maintain the DTU tier. If you have very small workloads, DTU is much more affordable than a 1 or 2 vCore model in the vCore model. But what's awesome about vCore is we're now looking at separation of compute or CPU, memory, and storage. So you have your number of vCores. You get 5.1 gig of RAM per vCore, and then IOPS per vCore. So in the general purpose, 500 IOPS per vCore. Your business critical, this is local SSD storage, so you get up to 200,000 IOPS versus 20,000 IOPS in your general purpose. Folks, if you have a high IO intensive SQL Server environment, don't even consider a general purpose or a standard tier. You're going to need business critical or premium to have the IO and throughput for SQL Server, unless you're going to completely kind of reinvent and look at how to reduce throughput requirements. SQL Server, we've said, CPU, you can tune that. Memory, you can get pretty good with, indexes and things. But from an IO, the read write, I mean, it can crush, storage, and premium storage for these, heavy used systems is going to be needed. So just keep that in mind when you start doing your proof of concepts. You need legit, traffic to put through to see how your system's going to handle that. Tuning differences for SQL database, anything from an instance level you can't do. So TempDB, cost threshold for parallelism, max degree, all of that. You can see it. You can do a select star from sys.configurations. You just can't change any of it. These DBCC free proc cache is not supported. Have you all heard about those things called database scoped configurations? Introduced in, or we got to see it in the on-premises with 2016. Well, that came from SQL database. So database scoped, well, database as a service. So you can alter database scoped configuration free procedure cache to basically run free proc cache against a particular database. DBCC free proc cache is instance. Well, there's not an instance in SQL database. It's database scoped. So it's going to be an alter database scoped configuration. Throw hardware at it so you can increase DTU, increase the number of vCores. You can look at overall file statistics. This is where the some of the things that we have with the Azure portal and the monitor lack. We can't really see what my latencies are and my file statistics over time. We need a tool that's monitoring that. So you can do it manually, still looking at the SysDM iOS virtual file stats, or have a third-party tool like DB Sentry that's collecting this so you can see time of day what your overall workloads are. The thing with DMVs is they're cumulative. Well, how long has this database been online? Weeks, months, a year? So you're looking at the overall SysDM OS virtual file stats is useless because it's from cumulative from the time that the database has been online. Same with your weight statistics. So it needs something that's kind of pooling this and doing the deltas in between, and that's going to be a third-party tool. I've written several articles out on SQLperformance.com. Glenn Berry, his DMV scripts include a bucket for SQL database and for managed instance. So you get familiar with those for looking at overall usage and tuning capabilities. But for the most part, things that we've been using are going to be much the same. It's still a SQL Server. Just be aware when you're looking at weight statistics, SysDM OS weight stats is for the container. You need to change that to SysDM DB weight stats when you're looking at Azure SQL database. So you want to look at database level weight stats, not from the container. It's a completely different set of data. The container won't have anything about your individual database. So make sure to change that, or you'll be chasing the wrong or going down the wrong hole trying to find that problem. So I kind of mentioned where's the best fit here for SaaS vendors. They need a database per client. It's a net new application. So many web applications fit here, and new products that you're working on where you can have a single database for that application versus trying to split everything out. Your elastic pools, kind of already mentioned this. When you have a lot of databases, you want a pool of resources. You can put those in. So I can have a pool of 1,000 DTUs or maybe 10 vCore, and then let all the databases in that pool kind of pull from it. You do have general purpose business critical. The pricing is same as the singleton database for sizing and pricing there. I'm not going to spend a lot of time here. The slides are available on my website, timradney.com. Just you click and you can pull these down, but just know that based on the size of the pool, there's different limits. So number of vCore limit the number of databases, which also can have a limit on the amount of storage. But this is great if you have multiple databases that you need to manage and you don't want to do it at a per database level. I had a customer that was in my first IA Azure class. They had a premium database per tenant. And when I mentioned elastic pools, this guy just kind of checked out, was just cranking on his keyboard for about 2 hours, doing some analysis, stood up and was like, if we implement an elastic pool, I estimate a savings of over $4,000 a month. So he goes back to the office, does more analysis, gets approval, they implement elastic pools, and sure enough, $48,000 a year savings. And after they implemented this, users started calling in saying, what did you change? This end of day process that normally takes 6 minutes took less than a minute. So the end users were ecstatic. They got a massive upgrade. And then he was happy because he's not having to micromanage these singleton databases. And of course, his employer was happy because they just saved nearly $50,000 a year in overall cost. I never got a nasty gram from Microsoft either. I'm sure they repurposed or reallocated that savings into additional spend somewhere else. But this is awesome, and this is available, vCore tiers as well. So your managed instance, so everything I just said about singleton database and database scoped, now imagine instance scoped. So your single databases, Azure SQL database, database scope, what do you have available, per database? Now let's open it up to instance level. So we want to try to get as close to on-premises as possible. So the goal, 100% surface area compatibility with on-premises, and they got really close. There's just a couple of things that still aren't there, may never get there, but we do have backwards compatibility to SQL Server 2008. So you need 100 compat level, you have it. You can do a direct migration from 2005 to manage instance. So notice direct migration, backup and restore, backup to blob storage, restore from blob, so backup to URL, restore from URL. A 2005 database will restore to SQL managed instance. The only thing that changes is the compat level will go from 90 to 100. So that's pretty impressive. Full support for cross-database query support. All your databases on a managed instance are on the same physical server, so think of it like a virtual machine. We got global temp tables support with managed instance that then was backported to SQL database. Prior to managed instance becoming, I think it was when it became public preview, it might have been private, we got global temp table support in SQL database. There's a SQL Server agent built in. It looks, feels, acts just like it does on premises, with the exception you cannot stop and restart SQL Server agent. It's always running. So with the SQL database, we had to get creative. We have service broker, transactional replication. It can be a publisher or subscriber. This is pretty cool because now we can have platform as a service, SQL database backend that can be a publisher as well. So we can have that data set or certain tables back on premises for whatever reason that we need. We got change data capture, SQL Server auditing, CLR support, database mail is there, functions just like it does on premises. There's managed instance auditing. All this can go into your Azure storage account. So for regulatory compliance and audits and things, the data's there. It can be picked up from there and put into whatever your log management is. If you're using Sumo Logic, Splunk, LogLogic, any of those things, you can leverage those tools to bring events into your SIM, or you can leverage Azure Analytics and learn a little bit of KQL and do your own analysis in Azure. And then TLS, so transport layer encryption, TLS 1.2 I think is now forced for connections on managed instance. I have to confirm that, but I believe I did see that it's now being forced. So from technical specs, you have two tiers. We have our general purpose and our business critical. Your general purpose storage up to 8 terabytes. You have anywhere from 4 up to 80 vCores. There's still that 5.1 gig of RAM per vCore. Your minimum storage, 32 gigabytes, and your maximum database size is your storage limit. Your IOPS here for your general purpose, they scale per data file. So 500 per data file up to 7,500 based on the size of the file. So if you need more IOPS, you can grow the size of the file. So it kind of reminds me of the short stroking back in the early SAN days where we would just kind of fill up the drives with some bogus data so that it would fill up the outside. So it'd be a shorter seek, so you'd end up losing about 30% of your disk, but it was just trash on the outside of the disk so that the seek rate was much faster. Here, if you needed 1,000 IOPS, we'll just grow your database file, have a bunch of wasted space in it, but now you're getting more throughput. So you're paying for the storage, but you pay for convenience. Then you can move to the business critical tier and get faster storage, 5,500 up to 110,000 IOPS. You get 13,000 or 1,375 per vCore. You do have a 4 terabyte limit right now in your business critical tier. Be aware that the advertising says up to 4 terabytes, and that up to is you've got to get up to 32 vCore before you get the 4 terabyte limit. 1 terabyte for your 4, 8, and 16 vCore. 2 terabytes up to 24 vCores, and then you're 32 and above for the 4. I've been on several calls where people made the decision to move to the business critical, and then they go to try to bring in that 1.5, 1.6 terabyte database. And on premises, they're running on a 4 or 8 vCore machine, and they're finding they got to bump up to 24 vCores, and that's quite expensive. And there's justification and logic around it based on, hey, this is local SSD, and we kind of factored how much storage we have per core and so forth. And I understood when it was explained to me, but it still doesn't help the fact that I have many customers with multi-terabyte databases that don't need a huge number of vCores, but they need the storage, they need the speed of the disk and so forth. So just be aware, everything with Azure is a math problem for cost, for figuring out compute and where things can go. But don't be caught off guard with this up to 4 terabytes. Things may change. They're always fluid in Azure, but I haven't seen any movement here in a while. There's also a 100 database per instance limit. There is, early on we were told, well, that's what we tested up to. There is a number of files in an instance limit, and you have 3 files per database, because your data file, log file, and then I forget the extension, but it's for in-memory OLTP and so forth. So you do the math. I mean, there's legit reasons why there's that 100 database per limit. Maybe you can squeeze out 103, 105, haven't tested it, but it's no longer just say, hey, this is what we tested to. There is an overall file limit. If you're moving to Azure, a SQL Server workload, there is the Azure hybrid benefit. So if you have on-premises SQL Server license covered under software assurance, you can convert those to vCore license in the cloud to be used for SQL database or managed instance. Just know that 1 standard edition license is equal to 1 vCore general purpose. So for the purpose of managed instance, 8 standard edition license would get you 1 8 vCore general purpose instance. An enterprise edition license, 1 core license is equal to 4 general purpose vCore. So it'd take you 2 enterprise license to get 1 8 vCore general purpose. So that it really kind of converts to most organizations' favor. If you go and do the math of how you're allocating virtual machines in your environment, and then oversubscribing and so forth, and you do the math, this roughly gets you, if you had 20 physical core license, so that's 20 enterprise edition license, you would end up converting over to 80 general purpose vCore. In the real world, that 20 might have 40 hyper-thread. You oversubscribe by 50%, so you're allocating 60 virtual CPUs on that host for SQL Server. So 60 now becomes 80 in SQL database or managed instance. If you're oversubscribing 5 to 1, sorry, this is going to be a painful approach, but most organizations, they'll find that it's a very generous hybrid benefit. So use cases here, you want to get into that platform as a service environment, but you need cross-database query support. You need SQL Server Agent, database mail. I mean, all those things related to an instance. Managed instance is your kind of your ticket as opposed to a singleton database. Compared to infrastructure as a service, where you're responsible for patching, for your OS patches, SQL Server updates, backup and restore. I mean, those things. I had a customer, we were doing a proof of concept, and they needed 16 vCore, 64 gig of RAM, and 6 terabytes of disk. So that'd be 3 P40 disk. The cost came in around $6,138. We looked at managed instance, a Gen 5 16 vCore, came with 82 gig of RAM. For their 6 terabytes of storage was $3,704. So it's quite a bit less. And then they mentioned that, well, I need high availability. Well, there's some HA built into managed instance. So for them to have any type of redundancy in IaaS, they had to spin up more compute and then manage that. So their cost would have even gone up even more. So there's, again, that math problem. What problem are you trying to solve? And then let's look at the overall, what options are available to you. It may be Azure Virtual Machine. It may be singleton database for some, maybe managed instance for others. Most likely you're going to have some bits of compute that are going to fall within all three. So key takeaways, Azure SQL database, very cost efficient, if you need that singleton database. If you have that singleton database, and a lot of them elastic pools are great for simplifying that management. If you need more, I need that cross database query support. I need SQL Server agent built in so I can do orchestration and kind of automation of tasks, of CheckDB, my statistics, my index maintenance, some ETL processes, massaging of data. I need those things, and I want it all built in, and I need that cross database query support. Then managed instance can kind of fill that gap. But regardless of your platform, we still got to be responsible for our index and statistics maintenance. Microsoft has publicly stated that they do various checks on corruption running CheckDB. They do really, really, really good at detecting and fixing physical corruption. Logical corruption, the only way to truly identify that is to run CheckDB. And you go read the blog post, it's there. But when it gets down to the part where they talk about their remediation, and part of their remediation may be running DBCC CheckDB with repair allow data loss, or restoring a backup and then rolling transactions forward and so forth. I'm like, so that means you all have encountered logical corruption and you're not publishing how quickly you're doing the scans. So my database may be small and seem insignificant to you, but it's my livelihood. So I'm still going to run CheckDB. I can't not be able to look at a customer in the face and say that, oh, well, I wasn't running this because Microsoft said they got it. And then they didn't. And then this customer is filing Chapter 13. When I could set this up in an Azure automation job or Elastic job, or run it from on-premises. So there's always a downtime. There's always a time to be able to run CheckDB at some interval. So I'm still going to do it. Might be overkill, but remember who my boss is. I don't really have a choice, right? So what we covered, we talked about paths, overall benefits, did a deep dive into SQL database, covered elastic pools, kind of did a pretty good dive into managed instance and how it's different. Was a lot of information. I just can't cover just one topic without a billion questions about, well, what about managed instance? What about this? What about that? And I still didn't dive into, with Azure SQL database, we have another tier called serverless that allows you auto scale. It's in preview. And then in managed instance, there's the ability to create an instance pool, which is in preview, but that means I can get 8 vCore and then create 4 2 vCore managed instance environments. So think of it as the Costco model. Again, that's preview, but this stuff is always changing. If you need a lot more, like 8 half days worth, like 30 hours of this stuff, then check out my, the IE Azure course. It starts up next week. We'll be doing it again in the spring, but this is where we dive into all of this stuff and all the security features with tons of demos and lots of Q&A and hands-on, type experience. But if you're looking at Azure, you have questions about this, you need more information, my contact information is here, tim@sqlskills.com. I'm on Twitter @tradney. I'm on LinkedIn. I mean, go find me, ask your questions. If it's stuff that I've blogged about, written about, got videos on, I'll send you links. Help you out with it. If it's something that I don't know and it's related to SQL database, managed instance, all of that, I have all the contacts for the program team at Microsoft. I'll go directly to them and figure this stuff out, because that's stuff that I also need to know, and you might be the inspiration for the next blog post or insider video. But I